Hey folks, this is an introduction to rational functions and their graphs, and you'll have two new parents in this particular section. The first parent that you're going to have here is called the reciprocal function, and the equation for that is 1 divided by x. So let's just look at a couple of things as we graph this. I've got an XY chart over here on the right, and if you were to plug in a zero for my x value, I would have 1 divided by 0, and we know that 1 divided by 0 is undefined. Now, the way that you draw an undefined place on your graph is going to be called an asymptote. I know that's a funny name, but wherever x is 0, there's this, we're going to represent our asymptote with a dashed line. It's like having a no man's land. You're not allowed to touch that particular part of the graph. And so anytime x is equal to 0, I have an undefined place or an asymptote. If you would think about the value of 1, an x value of 1, and you plug that in, that will be 1 divided by 1. And so the x value of 1 would also be a y value of 1. And so I would have a coordinate at 1, 1. If you have the x value of 2 and you plug that into your equation, that's going to be 1 divided by 2. So at the x value of 2, your y value is 1/2. And if you think of continuing on with that, an x value of 3 would be 1/3, an x value of 4 would be 1/4, 1/5, 1/6, 1/7, 1/100th, 1/1000th. And I think what you can see is that I'm getting closer and closer and closer to the x-axis, but I'm never actually going to touch the x-axis. Now the reason for that is not only do I have a vertical asymptote whenever the x is 0, but there's also never going to be a time that you can make your y value equal to 0. So there's not only a vertical asymptote at x equals 0, but there's also going to be a horizontal asymptote at y equals 0. And so from the x value on, what we have here is it's a graph that's getting closer and closer and closer to that asymptote, but it never actually reaches it. Now, I'd also like to look at the values between 0 and 1. I didn't really discuss any of those, so let's look at an x value of 1/2. And if I plug that into my equation, that's 1 divided by 1/2. And 1 divided by 1/2 is 2. Or 1 divided by 1/3 would be 3. And so if I plug in an x value of 1/2, I get a y value that's 2. If I plug in an x value of 1/3, I get a y value of 3. And hopefully you can see here that's what is happening is I'm getting closer and closer and closer to my vertical asymptote, and I'm never actually reaching that either. Now let's go over to the negative side. So if I plug in an x value of -1, 1 divided by -1 is -1. And so you have a coordinate here at -1, -1. And I can follow the same pathway that I just got finished doing for the positive side. So if I have an x value that's -2, my y value will be -1/2. Or an x value of 3, my y value would be a -1/3, etc. So you can see that this part of my graph is getting closer and closer and closer to my horizontal asymptote. If I have an x value that is a -1/2, once I divide, I will end up with a -2. And so this one as well is going to get closer and closer and closer to your vertical asymptote. So this is the parent graph along with some special points. I would say that the most special points that you need to be concerned with are going to be the 1, 1 coordinate and the -1, -1 coordinate. So those are the two special points that you need to be concerned with. Now let's go ahead and use our graph to get into domain and range, but before I do that, I'd like to ask you your embedded question. Your embedded question for this particular section is, what are the 3 things that I required you to memorize when it comes to parent functions? What are the 3 things that you had to memorize about every parent? Bring that with you to class. Now, as we look at the domain on this graph, notice that I'm beginning at -infinity. Remember, domain is x value, so we're moving from left to right here. And so my domain is -infinity And it's going to, I can't just go all the way to positive infinity because I have that asymptote. So I have to skip over the value of 0, the x value of 0. That's a no man's land. You can't touch that spot. Your range, we're going to start at the bottom and we're going to work our way up. And once again, we're starting at negative infinity. We will continue to positive infinity, but we have to skip over 0. Where is our graph increasing, decreasing, and or constant? Well, first of all, there is no constant places. And as we read it from left to right, there's also no increasing places. All of our graph is decreasing. So we are decreasing from negative infinity to 0 and from 0 to infinity. And then we can say that the vertical asymptote is, I already mentioned this, it's on the y-axis, and that's going to be at the equation x equals 0. The horizontal asymptote on the x-axis at the equation y equals 0.